Good afternoon. I'm going to walk through the partial fraction expansion of P of Z from practice problem 10.32b. So we need to represent P of B as the sum of two terms where each term only has one factor in the denominator. So our goal is to get P of Z looking like this. A over 1 minus A Z inverse plus B over 1 minus Z inverse. And if P of Z is going to be equal to, if P of Z is equal to both of these, then we know that 1 over 1 minus A Z inverse times 1 minus Z inverse is equal to A over 1 minus A Z inverse plus B over 1 minus Z inverse. And now what I'm going to do, I'm going to multiply both sides of this equation by my denominator of my left side. When that happens, I'm going to be multiplying this into the numerator of this term here. So that means I'm going to have 1 minus AZ inverse times 1 minus Z inverse over 1 minus AZ inverse times 1 minus Z inverse. So that's all going to equal 1. So I get 1 is equal to A, and now I'll multiply this by each one of these, right? So A, 1 minus A Z inverse, 1 minus Z inverse, and that's over 1 minus A Z inverse, and this is its own term, plus, or its own factor rather, plus B times 1 minus A Z inverse times 1 minus Z inverse, and that's its own term, and so that's 1, right? Now looking right here, look, bang, those go away. So I get that 1 is equal to A 1 minus Z inverse plus B 1 minus A Z inverse. And I can distribute, but first I'm going to add a 0 times Z inverse. So this is the same thing as this, because 0 times Z inverse is equal to 0, so I still just end up with 1, but it'll help us in the end. So now I do A times 1 is 1, and then A times Z inverses plus B times 1, and then B times this term, minus, let's put the Z inverse in front, and then we'll do B times little a. And I'm going to group like terms now. So I get A plus B. I'm going to factor out my Z inverse from each one of these. So I'm left with A plus B times little a. So now I have two equations, two unknowns, so I can solve. And I have this term, right? This has a Z inverse in front, and this has a Z inverse in front. And then these are supposed to be numbers. We have a number here. So we have 1 is equal to A plus B, and we have 0 Z inverse is equal to negative Z inverse A plus B times little a. Well, those are going to cancel. Those are going to go away. So now I have 0 is equal to A plus B times little a, and then I get, if I subtract b times little a from both sides, I get negative b times little a is equal to a. Right here, over here, I can 1 equals, I'm going to replace, I'm going to use this, I'm going to plug it in for a, so I get b minus ba, factor out b, and then I get that b is equal to 1 over 1 minus a. Now I have a b. It's a term. It's represented as a function of a, so that's good. Now I take this and I'm going to plug it back in to this equation. So I get negative 1 over 1 minus a times a is equal to big A. And that just becomes, this just multiplies, a just multiplies right in the numerator of this term. So I get that. And then what I end up with is that PZ is equal to negative a over 1 minus a all over 1 minus a z inverse, and then plus 1 over 1 minus a all over 1 minus z inverse. Or I could rewrite it as this, because my numerators in each term don't have any z's, well then they're just going to be constants. They could be complex numbers or whatever, but they're just consider them numbers, and you can pull out minus a over 1 minus a times 1 minus 1 minus a z inverse, and then plus 1 minus 1 minus a, or excuse me, 1 divided by 1 minus a times 1 over 1 minus z inverse. And now when I go to find p of n, and I do that by taking the inverse z transform of p of z, well, that's going to be equal to, let's say, and then applying linearity and the principles of linearity, we can, that's the z inverse of a sum is the sum of the z inverses, and then because this term here is a number and this term here is a number, it's just a scaling factor, so you pull it out and you get minus a over 1 minus a times, that looks a little more like an L than the Z. The inverse of 1 over 1 minus a Z inverse plus 1 over 1 minus a times the Z inverse of, or the inverse Z transform, excuse me, 1 minus Z negative 1. Yep. So that's that. If they're right-sided functions, we can go a little more. Get this back up there. If they're right-sided functions, that's saying positive values of n. then using your table, you just get negative a over 1 minus a. What's this one? This one is, if a is a magnitude, if we're assuming a is magnitude a, or magnitude z is less than magnitude a, then we get, what would that be a times n un plus 1 over 1 minus a, and then this, the inverse z transform of this term is just u of n. It's the unit step. All right. Thanks. Hope it helps. Sorry, it's kind of messy. Still getting used to writing on my little tablet here.